Okay, guys, let's get started with the lecture. So today we will continue talking about segregation dynamics, this whole segregation process, the stuff that we introduced the last time already. We talked already about it on Tuesday, how one person moving changes the situation for another person, and then that person suddenly becomes unhappy, and that person then moves, which again changes the situation for people around, and how you can have these chain reactions of people becoming unhappy, right? And at the end, you have these very weird outcomes where people are actually very tolerant, but collectively we end up in a highly segregated world. So that's sort of like the essence of this whole thing, and it sort of really nicely illustrates, which is why it is often used as the example in analytical sociology, how sort of you need to distinguish these levels from each other, right? How sort of it's not just the aggregation of things, because people can be very tolerant, but nevertheless you end up in a highly segregated world. So I will briefly come back to the segregation process. I will also repeat a little bit about agent-based models, or about models in general, because I know this is sort of like different, or you might not be used to what that is, right? Or the whole idea about how we go about modeling. And then we further jump into basically the reading of Thomas Schelling, the Nobel Prize winner, of one-dimensional segregation models and then two-dimensional segregation models. It's essentially what I've already showed you the last time, but now we spend a little more time on it. And lastly, when we have some time, I talk to you a bit about some ongoing research. It's really just some work that, I presented a couple of years ago. I've never really written it up. So if one of the master students is excited about jumping on that, I would be more than happy. I would love this to turn into a paper and get published eventually. Okay. So the segregation process, just to summarize it again, we have segregation as, the separation of individuals into distinct part of social life, but it is something static. Right? It's something that we observe. While the segregation process, in contrast, are the actions that create and sustain segregation. And so that's the difference between them. Segregation process is how the whole thing comes about. When you see our little Coleman boat, this is our micro-macro schema, segregation is up there. This is the segregation process. Yeah. Okay, so now the key component in that, you always need to think about, when you look at these dynamics, how are people affected? By what are they affected, right? And when we look at the segregation process, talked about people moving around and that potentially having an impact, right? We're not born in a segregated world and this is sort of how it is for eternity. No, people move around, right? Individuals, they have agency. That's also like a core component. Remember one of those 4-5 components, Gianluca Manzo, yeah? They are individuals. Individuals do something. Society is there, yes, but it's not society that acts. Individuals do something. Yeah? You need to have individuals to do something. And what do they do in our case? Well, they actually do two things. They go away, and by doing so, they change the composition of the neighborhood that they leave behind. Now, if I leave a neighborhood, suddenly the composition in that neighborhood is different, because I'm not there anymore. Yeah? So that kind of changes. You say goodbye to people, but at the same time, you say hello to others. That means you move into another neighborhood, and by doing so, you change the composition of the people who live in that neighborhood. Just think about this process, how certain parts of the city become gentrified, they become cool. And why do they become cool? Because, lots of people move there, and then it changes the whole nature of it, and then more and more people go there until at some point nobody can afford it anymore, right? That's sort of like this process happening there, that the composition of a neighborhood changes the feel of a neighborhood, which is totally the case. Okay, so much about the segregation process, and keep in mind that these two things is where essentially individual action changes the social context of other people. And individuals, they behave within social context, but then again, they change the social context of other people in these two ways, by either leaving or they change the composition of the neighborhood that they leave behind, and they change the composition of the neighborhood that they enter. Okay, so now let's talk about agent-based models, or about models in general. Yeah? So now I'm kind of doing a little bit of an excursion, not too much, but just because I think maybe you guys don't really know about that. And it's something that often people have difficulties to grasp, right? Because you see, it's not just sociology. Actually, it's even worse when you go to the sciences. Yeah? It's even worse when you go to the sciences and they come up with a model of the world. They actually come up with a model of the universe. They have it's the big thing. They want to unify the forces in the world, There's, I don't know, there are equations that kind of tell you about how electricity works or how electromagnetism works, these kind of things, or how gravity works, right? That's sort of like what they come up with. And then we kind of take it as an explanation. But hang on, I don't know, that's not an explanation, really, to be honest. That's really just a formulation of something that produces something that looks like the real world. Yeah? As it turns out, I don't know, the equations that we have from Newton on gravity, they're actually pretty good in kind of saying like why certain things fall in which speed or so, right? But for us, it's the same thing. Yeah? For us, it's the same thing. What we do is we think about how the world works, right? But the world works in, I don't know, sometimes mysterious ways. Maybe sometimes it works exactly the way, because I don't know, the way I think it does. Maybe sometimes it doesn't, right? But what actually I, as a researcher, do, actually all researchers do, and there's no distinction between social sciences, the sciences, or anybody else in a way, or even medical folks, they kind of have no idea. They kind of just try out certain medications and realize that works in a way, and then they come up with a model of why that actually could work. And what is a model? A model is essentially a representation of the real world that we built. Just think of this little toy model. It's actually not that far from that. Yeah? You don't really know how an airplane works, but you kind of try to rebuild it with all the little building blocks that you can control. That's the key. So I kind of try to rebuild the world as it looks, right? And by doing so, I build a model. And now the interesting thing is when I rebuild that, I know exactly what's going on because I put the pieces together, right? And at the end, the challenge of a researcher is to kind of to find the way how you would have to put the pieces together so that what the outcome that you have is actually close to the real world. I know that's sort of a little strange and like, hang on, what's going on here in a way? Don't we explain something? Don't we know what's going on? Well, actually, the only thing as a researcher that I can tell at the end of the day is kind of what are the things that build something that looks like the real world. And then the agreement is that if I kind of build something that looks like the real world, that then we kind of say, okay, I explained the real world. So that's sort of a little odd, but actually it goes through the whole sciences. It's like actually the essence of statistical modeling. When you run a regression analysis, you have a dependent variable, you have independent variables. All you do is find a way to produce some outcomes with certain simplified rules. A model is always a simplification of the real world. And that's sort of like the key. We want to find the simplest way of how we can reproduce the real world. And sometimes we say, okay, well, the real world varies around that somehow. There's randomness in it and so on. But essentially, we want to build something that looks like the real world, and then we can say our independent variables matter for that. So it goes through all statistical models that you have. So we basically really try to recreate the real world in our little head, with our statistical models or with our computer simulations or whatnot. And then when we know that, we can say, okay, hang on, these are the little pieces that we tweaked. That means that little thing here matters for the real world then as well. That's sort of like the jump that we then make. Okay. So much about models, but let's leave it like that. There's a whole philosophy, class. We could talk about that, right? Then when it also comes to causal inference, about how do we actually know something, the philosophy of social science, how do we know something? It's a very interesting topic. Unfortunately, we don't have the time here right now. So what we are interested in now is what is called agent-based models. Now there's a particular kind of models that we use, but at the end, it's not too different from a statistical model either. Agent-based models, it's a technique. To be more precise, it's a simulation techniques where we try to simulate the real world, or not even the real world, but we just simulate a collection of agents and the relationships between them. Essentially, what we do, we build a fake world. We build the matrix. Think about the matrix, exactly like the matrix. You build the matrix, and you'll see, okay, what happened if my agent would do this? Yeah? Or what if my agent could jump 20 meters? How would that change that? How would that change the outcome in a way? That's exactly what it is. And then it's like a toy world that we create that is often highly, highly stylized and abstract. And why do we do that? Because, remember, we are interested in these interactions. And actually next week we'll talk a lot more about social networks. I will come closer to my work. Social networks are how people are affected by others around them, how they are related to others and so on. And very quickly, things become very complex, where you can't really tell anymore with your intuition what would be the outcome if one individual behaves like that, because you don't really see, you cannot preempt all those chain reactions that happen afterwards. And hopefully today you will see that, because today we'll have a bunch of really counterintuitive results, where we change something at the individual level, but collectively, if people interact with each other, something very different comes about. So in agent-based models, essentially computer simulations, you have agents and you simulate them. It's really like little Sims. Think about it like Sims. You played Sims. Do people still play Sims? Does anybody play Sims? That used to be a thing. I never played it. Yeah, I played SimCity, actually. Yeah. So, but Sims is this thing where you have a little character and you go around, you chill in the, I don't know what one does. Some people spend their whole life in there. There's even Second Life. It's a big online thing. It's very interesting to do research on it, because it is essentially a quasi-experiment for the real world. Yeah? And actually, some people do really cool stuff on it. Yeah? They really do experiments within that fake world. Anyway, for us, the guy that is the most interesting right now, he's a crucial figure in agent-based models because he popularized that like a long time ago, long before there were any computers in a way. So this is like in his mind, Well, he has a good mind. The guy is a Nobel Prize winner, Thomas Schelling. Unfortunately, he died, but yeah, he's a great guy. Once I had a chance to meet him, I think I told you the story, right? How I had the flu and how I kind of coughed at him and then he died. So I don't know. I hope that it was somebody else's virus. Yeah. Anyway, the guy wrote this book, Micromotives and Macro Behavior, which is a fascinating read. It's probably my #1 book. Yeah. I think it's really, really cool, very fascinating. I can read it again and again and again. And it's, there's always new things you can pick up. Yeah, it's not overly complicated, but actually still there's something that you can pick up in it. Okay, so now we jump a little bit into that. Finally, that's only one part of what a Nobel Prize winner does. He didn't even get the Nobel Prize for that. His most important work was in game theory on nuclear deterrence during those days, conflicts. He was working a lot about that. Okay, so now we kind of take a step back. So what Schelling does, so he introduces a one-dimensional segregation model and then a two-dimensional segregation model. And I'll walk you through that, just to re-emphasize what's going on. The one-dimensional is even more simpler, even more abstract than what you've seen so far. And then the two-dimensional one is pretty much what you already saw. And then we extend that. Okay, so what is going on here? It's always like the same 3 steps that happen, right? I don't know, I live somewhere and I evaluate my neighborhoods. This is social context mattering for me. This is like the arrow going from the macro level down to me. I live somewhere, and that affects me. That's the social context that I'm living in, if I want it or not. I don't know, I'm embedded in that. We'll talk more about embeddedness next week, actually. So you are embedded in that, and this is the world for you. Yeah? So you evaluate your neighborhood, what you see. Okay, based on that, individuals, they actually do something. The individual action based on their evaluation. And notice how this evaluation doesn't even have to be right. Right? This could be that they're actually wrong. Yeah? And there's actually this, did I tell you the story about if men define situations as real, they are real in their consequences? Oh, I think I didn't. It's actually the story why I'm a sociologist. It's kind of a little weird because actually I did my first degree in computer science, believe it or not. I have a degree in computer science and business, and then I ventured off to become a sociologist later on. And I was sitting in my computer science classes that I actually liked a lot. I still like that. I still like to hack away and play SimCity, as I do. So I was sitting in these computer science classes, and I had all these ideas about the social world, but I didn't really know what it was. I didn't know what sociology was. I don't know if you guys knew what sociology was. I had no fucking clue. Yeah? And my parents still don't know what it is. Yeah? But they see, okay, the guy makes a living, okay. So apparently it's working. So I had no idea about sociology, about, I don't know, what the stuff, as it turns out, the ideas that I had were sociology. And I started writing them down. I started writing them down in these little Moleskine books, but now I have 15 of them, all filled with ideas, where one idea comes from the next and one from the next and so on. I think I need a few lifetimes to work through that. But the very first idea in the very first book where I wrote something down was something along the lines that doesn't really matter if something is true or not, as long as you believe in it. It's pretty much the same for you. Right? I don't know, it doesn't really matter if people like me or if I just think that people like me, or if I think that people dislike me or they dislike me. It doesn't really matter for what I do at the end of the day. Right? When you're sort of embedded in a social context, that actually your experience of the social world really matters for that. So I wrote that down. It's a very simple idea. I kind of developed other things from it. I didn't really know that I was using deductive reasoning or deductive logic. I had no clue about it. So then at some point I realized, first of all, this is social science. That's actually sociology. And then I realized that somebody already had that idea 80 years ago. Yeah? So I was a little late. Yeah? Then I thought, shit. Yeah? I had this really cool idea. Yeah? But I'm 80 years too late. Yeah? As it turns out, it was a very famous sociologist who had that idea. And the guy was based in Chicago, like the hub of sociology in those days. And his name was William I. Thomas. And in the literature, the bloody thing has a name. Quote, if men define situations as real, they are real in their consequences. That's what William I. Thomas wrote. And it's in the literature, you can find in Wikipedia, it's called Thomas Theorem. So I thought, I'm 80 years late, but at least the bloody thing has the right name. So I thought, okay, well, maybe this is what I should do. Yeah? And that's how I went off into sociology. Finished my computer science thingy, but that's how I became a sociologist. Yeah? A couple of other stories. Actually, there's another one around SimCity. Let me tell you that one as well, because it's funny. So actually, I was, as a teenager, I was interested in lots of different things. I think I still am interested in many different things. And I think you need to be open as a person to many different things. But in those days, I wanted to become a physicist. So I wanted to become one of those particle physicists, that finds the Higgs boson and so and things like that, like really extreme and, I don't know, flight to the moon and all this kind of shit. Yeah. So I actually did an internship at this nuclear research institute in my neighborhood where I was. And I went there. I wasn't in the nuclear unit, but some other, high-end physics laboratory on thermo and fluid dynamics and so on. So I arrived there. I was supposed to have the internship and learn from them. And as it turns out, just a day before I arrived, they had an accident in their lab. So they couldn't let me in the lab. It was a safety hazard. So they didn't really know what to do with me. So they put me in the office. And there was one computer. And on that computer, there was one computer game. And that computer game was SimCity. If you know SimCity, you build your artificial world, right? Your population, you play with that, they grow. And here I am simulating societies. Yeah. So actually, this is where we're going now. So maybe it all had a reason. Okay, so people evaluate their neighborhood, and then they base actions based on that. And then individuals, these actions, they change the neighborhood. Right? So we are not just slave to our environment, to our social environment. We also change that. I think we don't have to argue about that. Right? You do something, other people observe that. You change the neighborhood. If you move to another neighborhood in Dublin, you change that neighborhood. Right? So you have an impact on other people. And there you see, now we have the feedback loop, because now others, they evaluate neighborhoods, and now maybe their evaluation changed because of whatever you did, because of the action that you had. And then we are in this feedback loop where the social dynamics unfold. Okay, so now what I'm going to do, I'm going to walk you through these 3 steps for Schelling's one-dimensional segregation. Okay, so evaluation of neighborhood, let's go about that. So Schelling has this very simple model that he proposes. Now you see, I don't know, just look at the bottom, you see hashtags and you see circles. Yeah? And now he just says, okay, it's a very simplified world where, I don't know, these represent individuals and they have, different attributes. It could be race, it could be gender, it could be whatever. It's just an attribute that they have. There are hashtags in the world and there are circles in the world. And then he says, okay, now let's simplify that in such a way that those guys, they live next to each other on a very long line. This is why it's called one-dimensional, because there's just one dimension. That's just a neighbor to my right, there's a neighbor to my left. Right? And then that neighbor has its neighbor on the left, neighbor on the right. And if you actually want to go on, you can make a circle and everybody has as many neighbors. You know? That's sort of like this basic principle. So this is now our very simple one-dimensional world. You know, it's very, very simple. And now we can say, okay, well, we have two ethnicities here, you know, hashtags and circles, and the ethnicity of each piece at the beginning is decided, you know, just randomly. So we create something like that just completely randomly. This is now a random generation. Yeah? Every time I threw a coin or a dice, and I don't know, that either made it a circle or made it a hashtag. Okay, so now we can look at the neighborhood. And you know, Schelling in his model, let's follow that. He defines a neighborhood as all 4 neighbors to your left and all 4 neighbors to your right, including yourself. So a neighborhood consists, in this case, of 9 individuals. For that individual here. Now, if you would go further to the left, maybe there wouldn't be one, it could be less, but it's up to 9 individuals. Yeah? Okay, so now let's look at the red individual that we see, the red hashtag. How many other hashtags are there in that neighborhood? 3, including the individual him, herself. So we have 4 hashtags. Does everybody see that? Now there are 4 hashtags. 1, 2, 3, 4. Now within 4 steps to each, including the individual him or herself. And how many circles do we have? We have 5. 5 circles in this neighborhood. Right? There's now a definition of a neighborhood that we have. We simplified that. You could have other definitions and so on. Right? This is now the one that we follow, the one that Schelling used. So there we are. Let's take another individual. And without that individual, when we kind of look at that individual's neighborhood, now we see again like 5 circles and 4 hashtags. So like the same composition of that. Okay, so this is now the very basic thing of the model. And now we can think further, okay, we have the neighborhood, we can present that as this could be households, this could be a residential environment, you know, just is like an abstraction of things. Now we want to model interdependence of these different units. Interdependence. And this is now the second step, you know, where individuals do something based on their evaluation of the neighborhood. And what we can now do is that in a dynamic process, you know, we model rounds where individuals do something. Yeah? They evaluate their neighborhood, and if they are unhappy, they do something. They go. Yeah? If they're happy, they stay. So the model proceeds in rounds, and at the beginning of each round, you know, that's something that Schelling describes. You know, he basically creates this fake, very abstract world to make a point. To make a point about how these very simple rules of when these rules of interaction occur, what the outcome actually is. So he comes up with this rule, okay, at the beginning of each round, each piece in a neighborhood where more than half of the neighbors have the opposite symbol is marked as unhappy. Yeah? And in such a way that, you know, that as soon as there are more, if let's say I'm a hashtag and in my neighborhood there are 5 circles compared to 4 hashtags, then I'm unhappy. Yeah? As soon as I'm in the minority. And these are the unhappy ones. If you would go through, actually I think I'm going to have an example of that in a second. So, but these are the unhappy ones. Yeah? So they're unhappy and they just want to get the hell out of there. And no, that's just about, I don't know how this is justified, you know, I don't know what this actually means, you know, actually one prefers segregated over integrated worlds. Now that's sort of like what is being embedded here. Or one prefers an integrated neighborhoods. That's not really the point that I want to make. So basically what he shows is that how these simple rules, you know, where an individual becomes unhappy when more different ones are in the neighborhood than similar ones, just a little bit, right? How that actually triggers these complex dynamics. And residential segregation as an unintended and even unfavorable outcome for everybody in there. So now let's go to the second step. So people evaluate the neighborhood, right? So I described how that goes, but now let's go to the second step, you know, where they actually make a decision or they do something based on how they describe the neighborhood, whether they're happy or unhappy with it. Yeah? And again, it's like not a stupid environment. If you think about back, I don't know, you could think this along gender lines. Yeah, you hang out with your friends. Yeah, I imagine your early adolescence days. You probably were hanging out with with friends of the same gender. Yeah? And probably were a little uncomfortable if there was too much from the other gender in that group. Right? And then you might have moved. Yeah? And so that's an example where that happens. Or you can also observe that in many other domains. So it's actually not that unrealistic, yeah? That we sometimes become uncomfortable when either we are too much in the minority or when actually everybody's the same. It's kind of the funny thing with Germans abroad. Whenever we are surrounded by Germans, we just get the fuck out of there. Yeah? I don't know why. Well, it's funny. Other nationalities are very different about that. You know, like the Spanish or the Italians, they just love to have their fellow countrymen around them, you know. But Germans just pretend that they're not Germans and even put on fake accents and things like that. It's really funny. I don't know, somebody should study it. Yeah. So individuals do something. Yeah? They evaluate their neighborhoods and they do something. So what do? So now, first we identify this guy as unhappy. Now you see the guy actually, you know, there are no neighbors at the very left. But you know, if we count it, there are five squares in this neighborhood of going maximally 4 to the right and maximally 4 to the left, including the individual, him or herself, and there are only 2 hashtags. So clearly that guy is unhappy according to our rule, right, that we had that, you know, at least half of the neighborhood should be of the same background. So that guy is unhappy. Take him out. Huh? So now what the guy does, according to this model that Schelling suggests, it's very simple. This guy just goes to the next position that he can find where he actually would be happy. As it turns out, this would be sneaking in here. Because now, when you look at this situation, now in that neighborhood, there are 4 circles and 5 hashtags. So according to our rule, that guy is happy now. Okay, so that's a very simple model already. It's a very simple model. You know, you see these things they have very simple rules sometimes, you know, but they're kind of complex dynamics that follow from it. And complex doesn't mean complicated. In fact, it means the opposite. So, but that individual moved, and now we're at the third step. By moving, that individual changed the neighborhoods. In 2 ways, remember, we talked about that earlier by saying goodbye to a neighborhood before and saying hello to a new neighborhood. So who is affected by that individual leaving? And now you see the purple ones, they are affected by that individual leaving. Because suddenly there is 1 less hashtag for them in the neighborhoods where they had a hashtag before. Some are affected because of the arrival of this new guy. By sneaking in between, actually those 7 dudes are affected. You could argue, hang on, isn't there this guy here as well? Right? I don't know, that guy, that hashtag over here, you know, it's still in the neighborhood, and suddenly there's this hashtag over there. Well, that guy is there, but that guy actually is affected, but it doesn't change things. It doesn't matter, because the other neighbor before was a hashtag too. So kind of just having another hashtag in the neighborhood. Yeah? So these guys are affected by either leaving or arrival of the piece, but it does not matter because the neighborhood composition does not change. So these are the 3 things that we can have. And now we enter the second round. Now we could go through, okay, who is unhappy now? And then we run it again. And then we again look at who is unhappy now. And that's actually all that Schelling did. And as it turns out, you know, when you start, this is now from the book, you know, when you start with that scenario at the very top, after only 2 rounds, you end up with a scenario that looks like at the bottom. So you already see, okay, this is pretty segregated. There are kind of chunks of hashtags and chunks of circles. This is the outcome of that. Okay, so that's the 1-dimensional segregation model. Let's talk about the 2-dimensional segregation model, and maybe then it becomes even clearer. So this is the 1-dimension question.
Yeah, wouldn't it have to be true in real life for everyone to have a 50% threshold?
Yeah.
That's
It's a very good point. You know, these are kind of things where these models are sometimes, they're very abstract, they're very stylized in a way. So actually then folks like me come along and ask exactly these kind of questions, and then we say, okay, now let's simulate that. What happens if we have a distribution of thresholds? Does that, let's say, some people have a very high threshold, others have a very low threshold, for example. Or let's even go on, and there was a very famous paper in the American Journal of Sociology about that recently, saying that it's not just a threshold, that I kind of stay and at some point I go. Yeah? It's like I have a propensity to go. So when I gradually become more likely to move. Yeah? And as it turns out, that actually matters greatly as well. Right? So these are then all kinds of things. There's a whole lot of research around where people then exactly study these kind of things. So how does that model behave when, for example, people have different thresholds? Okay, so we have the two-dimensional model. Now we are in this grid, and to explain that, I have a little video. Let's watch that.
Four decades ago, on a long-haul flight, the economist Thomas Schelling was doodling with a pen and paper and thinking about the problem of racial segregation. When he got home, he picked up a chessboard to continue his investigations. And you can do the same thing. Simply lay out alternating black and white counters, or brown and white eggs, remove any 20 and add 5 just to mix things up a bit. The board now represents a mixed neighbourhood. Now, these brown eggs aren't extreme racists. They're happy to live in a mixed neighbourhood, but they don't want their white neighbours to outnumber their brown neighbours more than 2 to 1. The white eggs feel exactly the same way, so take any egg that is outnumbered more than 2 to 1 and move it to the nearest acceptable location. As you do this, you'll find something astonishing happen. The brown eggs and the white eggs will separate out like oil and vinegar. Even a mild preference for the colour of your neighbour can lead to extreme segregation. Thomas Schelling's chessboard experiments became famous, and Schelling himself eventually won the Nobel Prize. For me, the experiments are about more than racial segregation.
So you saw a little illustration about that happens. Actually, in this case now, it's even more extreme. It's like, I don't know, I'm happy with 2/3 who are different to me. Right? And as it turns out, this is like a crucial cut point. As soon as you go a little bit above, you kind of end up with highly segregation. If you go a little bit below, you end up in far fewer segregation. Let's walk that through a little bit. So now we have like the illustration. Now we have like yellow and blue individuals, and this guy in the middle, that's now the guy that we look at. And this thing around, it's what we call the neighborhood. Actually, it has a technical term. It's called the Moore neighborhood. And again, people kind of vary that. They change that. What if I look at 8 people, more people around? What if I look at, I don't know, gradually people around? People kind of look at all these kind of things. That's what we do all day long, right? And then, so this is the neighborhood of this guy, the Moore neighborhood. This is now another guy. This is the Moore neighborhood of that guy. Yeah? Okay. And now we can have a very simple rule that the individual wants to move if less than 1/3 of the neighbors are like that individual. Yeah? So in the case on the left, the triangle in the middle is unhappy. In order to show that, now I'm actually showing you a website where we actually look at that. So here we are. I'm going to post this on the Blackboard as well, but because now you see this guy here is unhappy, according to that rule. So we move that guy over here. Now the guy is happy. Yeah? Okay. There again, we have like scenario, this guy is unhappy, he would be unhappy there. Actually, now this guy became unhappy. Yeah? Oh, yeah, let's move them together. So here, actually now this guy is still unhappy. Okay, so here now we have like a bigger board. Again, like they are randomly assigned. We can have a new board, I don't know, let's create a new one. But now you see like this, according to that very simple rule, that guy would be unhappy. Where could we move him? Saying over there. Great, now actually that guy became happy as well. But this guy is still unhappy. Let's move that guy over here. So we could actually do that. It's exactly what the guy did in the video with the X. We could go ahead now and play around with that. Yeah? Okay, there's another scenario. Let's say we start with a situation like this. You see this guy is unhappy, and that guy is unhappy. So, okay, let's move that guy. He would still be unhappy there. So he's happy over there, and that guy is happy over there. Yeah? So that's sort of like the logic of that. Now let's kind of, instead of individually moving things around, now I actually have the computer move things. You saw what happened, new board. Now I start that, and now basically there's going to be one unhappy guy is going to be selected and it's going to be put somewhere else where the guy is happy. That's very simple. And then we have like here time, that's like the one axis, and here this is a measure for segregation. 0 means, I don't really know what the measure is, but 0 means here like random assignment, like right now, like they're randomly assigned, while 100% would mean like they're completely segregated. So again, let me play it. You see what happens, they move around. So actually, this kind of rule that kind of individuals are fine with up to 2/3 other individuals in their neighborhood actually leads to a remarkable segregation. That's what I already showed you the last time. Okay. How does it actually work? How do we end up there? Well, let's look at this scenario here right now in the middle. So actually, it's pretty much everybody's happy except this guy here. You see, this is the only guy that is unhappy. There he is unhappy. Oh. So what do? Well, let's move the guy. Well, there are only 2 empty spots here and there. So we move the guy over there. Okay, did you see what happened? Now this guy has, like, in his neighborhood 1, 2 blues and 1, 2, 3, 4, 5 yellows. So now there are more than 2/3 yellows. There are 5 out of 7. That's greater than 2 out of 3. So now this guy is unhappy. Okay, what can the guy do? Well, over there he's still unhappy, but he can go over there. Actually, those guys are unhappy now too. I didn't look at them, but this guy is unhappy and that guy. God, we started with 1 unhappy guy and suddenly now 4 people are unhappy. God, let's go on. Let's move this guy over there. Let's try to sort this out. This guy, we cannot really move that one. That one, we can make that one happy. Okay, we can make that one happy. And actually, if you would play that out, we started off with a pretty mixed environment where just one person was unhappy. And suddenly, we have like this chain reaction where people just keep crying, oh, God. Until now everybody's happy. So you saw how that actually happened. It's kind of crazy. Just one guy was unhappy, with a very simple rule. I just wanted to have at least 1/3 of my neighbors be like me, right? I'm fine with being in the minority, actually. I'm fine with having less than 40, 50%, as long as there are some people around me similar than me. Okay, so now what we can do, now we can actually change this threshold, a bit like what you talked, but now we change that for everybody in the same way. So here it's set up, okay, I move as soon as 33% of my neighbors are not like me, right? That's like the original setup. You see, actually, we end up in some sort of segregation. We can replay that. There we go. Okay, now let's move it a little below. Let's say instead of 33, let's go to, I don't know, 28. No, it's not a huge difference. So actually, people are just a little bit more tolerant right now. Tiny little bit. It's not a huge difference that suddenly they are twice as tolerant as before. So it's a tiny little difference. So remember, first we had like, I don't know, 45% segregation here. Now let's see what happens now. Okay, we still get a decent amount of segregation, 40%. Now 28, sometimes it's more, sometimes it's less. Let's go in the other direction. Let's go in the other direction and go instead of, I don't know, 33, let's say we go for 36. So now we went up from 33 to 36, but actually, we actually really have more segregation now. It's a tiny little change in the one direction, but the collective outcome is dramatically different. You could replay that, I don't know, obviously, because sometimes random chance kind of matters here, how the initial allocation is, and so on. Okay, so there are a couple of other things that we can do, but this is now an interesting one. Let's look at that. So now we are in a segregated world. This is the outcome of it, right? This is the outcome of this thing where people, they have like a preference for at least 1/3 people around them. Maybe now you come along, you're a sociologist, you just graduated from UCD, you think, great, I'm going to change the world, which I hope you will do, but not like this. And then you say, let's make people dramatically more tolerant. Let's say overnight we could change the world. We could make people more tolerant. What would actually happen to segregation? Right? So now let's make them more tolerant. Now I'm moving them into that direction. And what happens? Nothing. Nobody's moving. You don't get people out of segregation. And last time a couple of people actually made that argument that maybe there was segregation to begin with, and now the world changed, but I'm still sticking where I am. So just making people more tolerant doesn't do the trick, obviously.
There's no condition of being unhappy there at all. So why would they do it?
Yeah, exactly. Why would they move? So, but I want to show you one other thing. In order to do that, I have a little question for you. I'm not going to put up the question right now, but I just want you to, so you remember like we had like let me play this again. Here we are, 37, I don't know, percent, and we get some segregation happening here. What is going to happen if I recreate a new board, and now let's say I put this to, I really make people racist, 80%. What do you think is going to happen?
They can't lose it. They don't go with this. They're going to stay put.
They're going to stay put. Somebody saying something else? Complete segregation. So we have actually, okay, one person says they are not moving at all. Well, actually, they can move. They just move somewhere. I don't know. And then they are unhappy there. That's sort of like the thing. But you say complete segregation. Yeah? Would people agree with that? We make people racist, and then they become complete segregated. Remember, before with 33%, we had like, I don't know, 50% segregation or so. Now I'm going to run that. We have far less segregation when people are more racist.
They're never happy.
They're never happy. What is going on here right now? They go somewhere, so there's not enough time for those clusters of racist people to form, because one of them is unhappy and goes. So before they can actually form these clusters of very similar people, the guy in the corner is very unhappy and goes, and this thing falls apart. And then the next guy is sort of there, and then that person is unhappy and goes on. So they can never find a place. So that's like one of those very counterintuitive results. We kind of make people more racist, but actually the world becomes more integrated. It's very counterintuitive. Yeah. And that's a lot what these kind of papers are about. And you would not have thought that. It's very simple rules that are going on there, right? And then we kind of think about, okay, what is sort of driving that? Here the key is that just so many unhappy people, they can never settle. Okay, we can play around more with that. I'm going to put up it's a really cool little website. So
Is that why genocide is the result? They just are so intolerant they just have to kill each other.
Ooh, that's a big statement right now. Yeah, I don't know. You have to keep in mind these are very abstract settings here right now. So it's always like a danger to kind of then too quickly kind of say, okay, this is why the real world is like that, right? This is now showing some kind of social dynamic that we can control. Again, this is like the model. Yeah, that's something that we can control because everything that is going on there are the rules that we define, in a way, right? But I would say it totally can explain dynamics in housing markets to some degree, although people do a lot of studies about that. There are lots of other things that matter and so on, right? So yeah. So let's summarize that. This model shows that higher levels of segregation can result from actually rather tolerant individual preferences. People are fine with only a third similar kind of people individual around them, but what the world that they end up in is far more segregated than that. Yeah. At the same time, I showed you this really weird thing that lower levels of segregation can result from intolerant preferences. So people are actually more racist, and suddenly the world becomes more integrated. It's like really weird. Don't quote me on that. That's like not a recommendation I'm making. Yeah. But it's just how the dynamics of this game here play out in a way. So for us, most interestingly, Schelling makes this link between the micro and the macro explicit, through this little toy example, this little computer simulation. And we can then use that to, think about what else would have to be true, think about implications that we're then going to go out and test. So the model of segregation improves on this original common sense theory that we had. Remember, there was like this very simple idea, there's segregation because people don't like others. That was a very simple idea. Okay, it's not the stupidest idea, but we showed actually it doesn't really hold because other things are not really true. Right? So this model actually improves on that, both empirically and theoretically. Empirically in the sense that it is consistent with the weak relation between prejudice and segregation that we observe in the real world, meaning we observe that there is segregation going on while actually people are not really that racist. Yeah? They are not that intolerant. Actually, I showed you data about that people became more tolerant, but segregation didn't go down. Right? So actually, this model is consistent with that. Because it actually would say exactly the same thing. You can change tolerance level from, 60 to 50 and nothing really big would happen because the whole magic happens somewhere else. at this tipping point, you know, where the dynamics kick off and suddenly you have the chain reactions or you don't. So it is consistent with that empirically, or the two regions can differ, and theoretically it's also, I don't know, something that we call the minimal program of sociology, that we try to explain macro-level phenomena as a result of macro conditions, you know, an individual micro-level goal-directed behavior. So his book was titled Micromotives and Macro Behavior, and the whole point of it is that micromotives are not equal to macro behavior. Or macro behavior is not equal to micromotives. In fact, they can be opposite to each other, right? And that's sometimes hard to grasp. I had a little bit, so I'll just spend 2 minutes on that, because that's sort of like what I want to present it to you. Maybe one of you is keen on jumping into that. So as I said, I've been playing around with these kind of things because I'm really interested in it. And I have this one paper that made it into stage of the presentation at some point, but never published it so far, where I asked myself, what actually happens, a bit like what you said earlier, what happens, I don't know, if the world is slightly different. What happens when individuals do not just care about one thing, for example, color, but also about something else? 2 dimensions. Yeah? I'm a multidimensional being. I don't just care about color. I care about other things too. Yeah? I hope you too. So we are multidimensional beings, which I think is often forgotten, you know, but I think that's just what the real world is. You know? So actually, I replicated this model, I extended it. So a simple case is that, I don't know, what you saw already, 20 by 20 letters is how we call it, Moore neighborhood, step function, I don't know. It's just that, but the key now is the following, that now there are 2 dimensions. There's color, there's red and green, and there's also size, big and small. Both are equally assigned, there are half of them equally there. So this is where we start. When you look at the left, there are like half of them are big, half of them are small, and half of them are green, and half of them are red. You know, they're just randomly assigned to these categories. There we go. There's no correlation between these 2 categories. Actually, in another experiment, I modeled a correlation between these 2 categories. What happens if size is correlated with color, for example? So I did that, and then the outcome is what you see on the right. We also have segregation, but interestingly, you know, we have segregation on both dimensions. Yeah? You see the big ones are sort of close to each other, but also the green ones are close to each other. So sometimes you have these borders, you know, there's like a small green and a big one, but they kind of still, so we find segregation along both dimensions. And then I played around with that, you know, like what is the decision rule? Let's say I have these 2 things that I care about, size and color. How do I choose one? I could say, okay, the simplest one is just everybody just chooses the same one. That's just a simple model that we've already seen. Or you can say everybody chooses something at random and they stick to that all the time. Right? So I say I'm a size guy or I'm a color guy. So I just care about color, for example. Right? But then you can also have that, okay, every time let's randomly assign that. Randomly reshuffle. Let's say every time we roll a dice, every round, every point in time, now we all care about size. Or now we all care about color. Or you can do it that every individual in each round kind of randomly cares about size, randomly cares about color. Or you can have it, and that's sort of like where, you know, I became a little innovative, kind of thinking about, okay, let's care about what the people around me care about. If I'm in a neighborhood where everybody cares about color, I'm starting to care about color too. Which is not that unreasonable, you know, I'm being influenced by my environment and so on, or by the people around me and so on. And then you can simulate that, you can model then what are the outcomes, what are the levels of segregation that we achieve. And when you look at that, you know, there are some counterintuitive results in it. For example, when you compare the fixed individual to fixed random, so actually you would have less segregation if they would be racist, but if they just stick to that one thing. If the color guys stick to color and if the size guys stick to color, actually we have less segregation than when every time they throw a dice on what they care about. What is it? Why is that happening? When you think a little more about it, it's actually relatively straightforward. You know, this is like, I don't know, remember this unsteady system where people are unhappy, they move around, right? And when you every time roll a dice about whether you care about size or color, you have more chances to keep the system going of having unhappy people. While when some people just care about size and others just care about color, then, you know, you reach the steady state faster. And then the system just dies off, yeah? This chain reaction dies off. We do get some segregation, but the chain reaction dies off in a way.